All right, geometers, on this day we want to prove triangles are congruent using, oh, snap, crackle, and pop. Guess what I forgot to do? Please delete that. And we have to make a change here, yeah. We are going to be using angle, side angle, and side angle, angle. Just give you a heads up. That has the name there can be angle, angle, side as well. All right, so we've already done side, 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 and side, angle, side. Today, we're going to look at two additional postulates that we can use, but we also want to look at and show why these two don't work. Besides this one being profane, we as geometers always watch our mouths. So we are going to take a gander at this first one here. So let me just read this one more time. If two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the triangles are congruent. So I'm going to sketch these out. They happen to be oriented about the same, but the importance is not that they are oriented the same. So here's a pair of angles that are congruent. Here's a second pair of angles congruent. So I have to say the included side is those sides there. So when this diagram or something similar to this is in play, my conclusion is that the triangles are congruent. Oh yeah, it's a good day. If two angles and a non-included side of one triangle are congruent to two angles and a non-included side of a second triangle, then the two triangles are congruent. Oh yes. So what would the diagram look like here? I have two triangles that look roughly close, and I have a pair of angles here, pair of angles there, and the non-included side, and it actually doesn't matter which one generally, but just like that. So notice my pattern. So sometimes this is not called it's called side angle angle, but it's also called the angle angle side. It actually doesn't matter which direction you're counting, because look, this is a pair of angles, pair of sides. There's no text here to write down because it would be pointless to write all that and say, in the end it's nothing. So what I just ultimately want to prove is to show a counterexample. Can I draw two triangles whose angles all match up and yet they aren't congruent? And the answer is, of course. Comment. So if I draw this puppy here and then this puppy here and then go along a pair of congruent angles, another pair of congruent angles, and lastly this itty-bitty acute angle is congruent. But clearly these are not congruent triangles. Not congruent triangles. They do have another name, just for preview, do you know? Similar. Good. These are called similar triangles. And we will get to that later. And that symbol, just as a preview, you don't have to know this yet, the symbol is just this. It's just that. The next one, we say, wait a tick. If I draw a pair of, so let me say a pair of sides, right? And then a pair of sides there. So like that. And then one of the other angles. So if I say, oh look, this angle is congruent to this angle. Look, I angled it down to go in the same way. And we say, but that's congruent, then it goes up here, that's congruent, and then I angle this one to be the exact same, and look, that works, doesn't it? Another example, if I had this side right here, congruent to this side right here, and then I had this side congruent, and don't extend that bottom one out yet. I just made a little bit right there. So notice, so far so good. I haven't finished the other one yet, but I have a pair of angles here, a pair of sides here, and I'm going to make this other side here. But instead of it opening in this direction, I'm going to make it go down this way. As if I swung this. Pretend this is a swing and it swings over this way, right? So notice I can get the same situation where this is the same size as this. These are the same size, and this is the same size. But notice this one has to be stretched out. It's almost as if I just swing it over right there. So I just took this guy and swung it over. And look, it's still angle, side, side. Angle, side, side. But am I talking about this obtuse angle triangle here, or am I talking about this acute triangle here? And the answer is, we don't know. So we can't say 100%. We can't say 100%. So the best we can say is maybe or not enough information. So let's practice down here. Do we have enough information? And if so, what's the reason? And let's state the congruent statement. And remember, a congruent statement says triangle such and such is congruent to triangle such and such. So let's see here. What do we know? Pair of angles. And then, of course, these two angles are also. Is there anything else that we know that's congruent? Anything else that we know?
WY is congruent to itself.
There we go. By the reflexive property, that's congruent. So if I can say yes, and the reason for it, let's follow the pattern and make sure the pattern works for both triangles. Pair of angles, pair of angles, pair of sides. Pair of angles, angles, sides. So this reason here is angle, angle, side, or you could say side, angle, angle. Doesn't matter. So now let's follow through, and what's the two triangles that are congruent? It doesn't matter where you start. I'm going to start at X, go towards Y, and then up to W. So following that same pattern over here, the Z corresponds with the X. I go towards the right angle, which is the Y, and then up the long leg there to get to W. And there's my answer. So what we're going to do here is we have two things that are congruent, and we're going to use this method. So in other words, what's the missing piece? What's the missing piece? So triangle DEF and triangle MNO. You can sketch it out real quick. So if we sketch out just triangle DEF, and again, I'm just making a random looking triangle, but not entirely random there. Okay, M and O. So just for ease of use, everything's corresponding and oriented the same. I'm told, according to this part right here, number 1 is different than number 2, so I'm not going to use the same diagram for that. That DE is congruent to NM. I'm also told that angle M is congruent to angle D, and I want to use the side angle side congruence postulate. So how do I do that? Well, if I go this direction, angle side, I don't want that angle or side. I need to go the included angle. So this angle has to be included, so that means my only option is to say DF is congruent to MO. So what's the missing part? DF is congruent to MO. So you might find that a sketch is going to be helpful for when you're working through these ones here.